Hey guys, today we're going to look at lesson 3, which is now adding and subtracting fractions. So the same rules apply that you would use for adding and subtracting regular fractions where you need a common denominator. So first we're going to look at examples where we have a common denominator already. So we're going to look at examples where we already have like denominators. Okay, first example, common denominator is 8x, so you're just going to subtract the numerators. So y minus 3y is negative 2y, and you keep your denominator just like you would with regular fractions. And at the very end, you look to see if that can be simplified at all. There is a common factor here of 2, so I'm going to cross cancel. Divide by 2 is 1, divided by 2 is 4. So my final answer is negative y over 4x. Okay, the second example, you have like denominators again, x plus 1. So you're going to subtract the numerators. This is to show you, this example shows that when the numerators are unlike terms, you just express them as a binomial. This is x minus 1, which can't really be subtracted. Over the denominator, keep the denominator x plus 1. Remember, this cannot be simplified. This would be your final answer because when you have binomials, you have to think whether it can be factored or not. These can't be factored. X minus 1 is not a factor of x plus 1 and vice versa, so that's it. Okay, you can only cross cancel binomials if they're exactly alike, and you can only cross cancel monomials with monomials. Like up here, we had a monomial and a monomial. In example 3, we again have common denominators. You have subtraction, and the one thing you have to be careful with subtraction is that the subtraction, remember there's really invisible parentheses here, it distributes to both terms in the numerator. So you really have 5x minus 4 minus 2x minus 1 all over 3, which then simplifies to equal 3x minus 5 over 3. This cannot be simplified. This would be your final answer. Again, even though you see a common 3 and 3, the 3 would have to go into both terms, or it would have to go into one of a GCF of the binomial numerator, and it doesn't. It's not. 3 is not a factor of 3x minus 5, so you leave it like that. Okay. Example 4. Again, we have a typo here. Can you guys please change this over to a minus? So we're going to distribute the negative and keep the denominator. I have a common denominator of x minus 1, and we have 6x minus 5 minus 5x, and that will become plus 6 because we're distributing the negative. So this will simplify to equal x plus 1 in the numerator over x squared minus 1. Now, if at all possible, you simplify, and that involves factoring. The denominator can be factored as difference of squares, x plus 1, x minus 1. So I do have a common factor. X plus 1 is a factor of x squared minus 1. So you cancel out the x plus 1s, and your final answer is 1 over x minus 1. If you have unlike denominators, that's our next section. Unlike denominators, you need to get a common denominator, just like you would with regular fractions. So what I like to do is I like to set up underneath the fraction, I like to set up the equivalent fractions. So here I would have a common denominator of 12. So I would set everything up over 12. So 2 times 6 is 12, so I multiply the numerator by 6. That will give me 18x. 4 times 3 is 12, so I multiply the numerator by 3. That's going to be 21x. And 6 times 2 is 12, so I multiply the numerator by 2. That's going to be 2x. Remember, you're allowed to multiply by that number because you're really not multiplying by 6 or 3 or 2. You're really multiplying by 1 because it's multiplying the numerator and denominator by the same number, and that same number over itself is 1. Now you can simplify this. So 18 plus 21 minus 2 is going to give us 37x over 12. Okay. Yes. I look to see if I can simplify possibly the two monomials together, and they can't, so I leave it like that. In example 6, I need a denominator of y and a denominator of y squared. So here, you want the least common multiple. what they would both go into. So you want something that's going to be at least as high as the highest exponent. So they both would go into y squared. So y times what is y squared? Y times y is y squared. So I multiply the numerator by y, and I get 8y. Y squared times 1 is y squared, so the numerator really just gets multiplied by 1. I still remain 5. Now I add their unlike terms, so I just express it as a binomial over the common denominator. This cannot be simplified because 8y plus 5 can't be factored, so I just leave it like this. In example 7, I would have a common denominator of, they all go into, 5 and 3 go into 15. So I would definitely have a 15. And then they would both need an x, a y, and a z. X, y, z. I'm going to move this minus sign over. And I say to myself, okay, so this first fraction would have to be multiplied. 5 times 3 would be 15, and then I needed to multiply by a z. I was missing a z. So the numerator is going to also get multiplied by 3z. That will give me 6z. In the second fraction, I needed to multiply by 5, and I also needed to multiply by x to get to 15xyz. So I multiply the numerator by 5x, and I get 35x. So when I subtract, I end up with negative, sorry, you can't actually subtract these because they're unlike terms. So I end up with positive 6z, positive 6z minus 35x over 15xyz. 6z minus 35x can't be factored. There's no GCF. There's no difference of squares. So these can't be simplified, and that's your final answer. Okay, example 8. Same idea. It's getting repetitive now, but I figured I'd give you a bunch of examples. Example 8, you have 21 is a common multiple. I would need y to the 4th. I would have to be at least as big as the biggest exponent. They both go into 21y to the 4th. So in the first fraction, I multiply by 3 to get to 21, and I don't need any more y's. So I just multiply my numerator by 3, which is 9. In my second denominator, I would need to multiply by 7 to get to 21, and I also need y squared to get to y to the 4th. So my numerator gets multiplied by 7y squared, and I end up with 14y squared. I can't subtract my numerators. They're unlike terms, so I just leave it as 19 minus 14y squared all over 21y to the 4th. This cannot be factored, so there's no common factors. Final answer. Okay, next example. We have a common multiple of, they both go into 12. And I need, now I have an a here, but I have an a squared there. So I need it to be at least as high as the highest one. I need a b cubed, because this has b cubed, this doesn't have any, and they both have 1c, so I only need 1c. So a squared b cubed c. So now in my first fraction, I need to multiply by 4 to get to 12. I also need one more a, and I need b cubed, and I don't need any more c's. So my numerator would be 28 ab cubed. My second term, I don't need to multiply by any number other than 1. I don't need any a's, I don't need any b's, I don't need any c's, so it's just times 1. So it's going to be 1. And then I'm adding, and they're unlike terms, so it's just 28ab cubed plus 1 over 12a squared b cubed c. Again, that's my final answer because this cannot be factored, and so there are no common factors with the denominator. And then in the next example, you have binomial numerators. And you just have to be careful here. You have to remember to distribute the negative after you get your common denominator. This negative has to distribute, but you'll do it after you get the common denominator of 12. So I have, this is going to get multiplied by 4, and it's kind of easier if you write it as distributive property. So if you write it as distributive property, so you don't forget that you're distributing into a binomial. And then the second fraction has to get multiplied by 3 to get to 12, so it would be 3 times x minus 2. But remember, this 3 is actually a negative 3 that's going to distribute in here. So you're going to end up with 8x plus 20 minus 3x plus 6 all over 12. And that simplifies to give you 5x plus 26 all over 12. My numerator does not have a GCF. It's not difference of squares. So that's it. Okay. And continuing with these types of examples now, another one similar to this. My GCF here would be, not my GCF, sorry, my LCM would be 24, and then I would need a cubed. Okay, so I'm going to set up my two fractions with 24a cubed. The first fraction needs to get multiplied by 8a squared. So I have 8a squared distributing into 3a plus 1. And the second one needs to just get multiplied by 3. So this would be 3 times 2a minus 5. Again, though, remember it's not really 3, it's really negative 3 distributing in. So I have 24a cubed plus 8a squared minus 6a plus 15 all over 24a cubed. And this is going to simplify into, this is squared, 24a cubed plus 8a squared. Actually, there's nothing, minus 6a plus 15. There's nothing to be done there, over 24a cubed. Now you could check, let me see, you could check if this could be factored by grouping. So just to double check, I'm checking 8 goes into both of those, so it'd be 3 and a, and 3 goes into these, but it would be 2 and 5. So that's not going to work out. That can't be factored. Okay, I'm just quickly checking some. Once in a while they can be factored, but not usually. Okay, so this cannot be factored by grouping. That would be your final answer. And finally, last one is, oh, you can ignore the last one. I don't know what that is. That's not supposed to be there. Okay, so, and I'll do some more examples with you guys in class today. All right, I'll see you later. Thanks.